In this video, we're going to talk about factoring polynomials, but we're going to specifically talk about factoring quadratic trinomials. Now, a quadratic trinomial, if you remember back to our first video that we talked about the vocab, quadratic has an x squared associated with it, and then a trinomial has three terms. So we've got an x squared, a 7x, and a 10 in this particular case. Before we jump in and start talking about how to factor something like this, we're going to talk about how to distribute this just one more time, kind of review this and see how this is connected to this. All right, kind of remembering back to the last video where we talked about factoring. Factoring and distribution are opposites of each other, so they kind of undo one another. So let's look at this first piece. We're going to do x times x and then x times 2. So that's going to give me x squared plus 2x. And then we're going to do 5 times x and 5 times 2. 5 times x is 5x, so I'll have a plus 5x. And 5 times 2 is a plus 10. So again, the nice thing with these is that those middle terms will always be able to be combined. So we'll rewrite this as x squared plus 2x plus 5x is 7x, so plus 7x, and then plus 10. And so the reason I show you this particular example is because we started off with these two sets of parentheses, and as we multiplied it out, we ended up with this, which is the same thing that we're asked to factor in this particular example. So let's talk about how to go backwards from distribution. Instead of starting with this, we're going to end up with that. That's going to be our answer, and we're actually starting with this over here. So the way I like to do this is I like to look at the problem and I say, okay, well, I know from past experience that when I factor this, it's going to have two sets of parentheses. I know that from multiplying out a lot of these guys right here. I know that I'll have a set of parentheses here and a set of parentheses here. Now the next thing I'll do is I'll say, okay, well, what makes up this and this? What needs to go there? And if I look back at my distribution problem, I had an x and an x, or what we end up doing is x times x gave me x squared. So I think of what times what equals that piece, and in our case it's just going to be x times x. So I'll have an x there and an x there. And now I'm going to do the same thing with the 10, but it's going to be a little bit different because I'm going to think of what times what is 10, and that's going to go there and there. If you look back at my distribution problem, it's 5 times 2. And then the other thing we're going to look at is, hey, it has to add up to 7x. And so the options for what times what equals 10 is 10 and 1 and 2 and 5. And since we want it to add up to a 7 when multiplied out, kind of like what happened right here, we're going to put a 2 there and a 5 there, or I can put it the other way. It really doesn't matter in the end, but I'll just write the 5 there and the 2 there, and they'll both be positive because we're talking about a positive 7 and a positive 10. And one thing I like to do sometimes is to just check my answer by distributing it all back out. Since I've already done that right here, I'm not going to do that in this particular example, but in your homework I highly encourage you to just multiply this out. And if you get what you started with, then you're good to go. So let's look at another example here. One of the things we always want to check is if the terms have a greatest common factor. So if you notice here, you have a 2x squared minus 16x minus 40. If you look at these three terms, they each have they're each a multiple of 2. So we can factor out greatest common factor, or GCF. And so that'll equal 2, and then it'll just be kind of a bigger set of parentheses there. And we'll think, well, 2 times what equals 2x squared, and that's going to be x squared. And we'll just kind of keep repeating that process. 2 times what equals negative 16x, and that'll be a negative 8x. And then 2 times what equals negative 40, and that's going to be a negative 20. So once we've done that, we can just factor this part here just like we did on the previous page. So I'm going to keep the 2 out in front. That can't go anywhere, but we're just going to have our 2 sets of parentheses based on kind of my distributive property. And I'm going to think, well, what goes here and here based on that x squared, and that'll be x times x. So I'll have an x and an x. And then I think to myself, okay, well, what times what equals negative 20? There's 4 and 5. One of those would have to be negative. There's 2 and 10. And 2 and 10, if you think about it, are really close to 8. If we had a negative 10 and a positive 2, that would add up to negative 8. So I'm going to have a negative 10 and a positive 2. And it doesn't matter what order I put those in. I could have put the positive 2 here and the negative 10 there. It's really just whatever works for you. And so that would be my answer. Before you just say, okay, we're good to go when we're done, let's check that. Let's use the distributive property, multiply that out, and see if we get what we started with. So I'm going to take 2 times x plus 10, and then times x plus 2. Oh, sorry, that's a minus 10, my bad. And let's just multiply that out. So I'm going to have x times x and x times 2. And this gives me 2, and then I'll have x squared plus 2x. And then I'm going to do the same thing with the 10, negative 10 times x, which gives me negative 10x. And then a negative 10 times 2, which gives me a negative 20. And then we'll just add those like terms in the middle there, those guys. And that gives me 2 times x squared minus 8x, and then minus 20. And then lastly, I'll just distribute this 2 to each piece. And that gives me 2 times x squared, or 2x squared. And then 2 times negative 8 is a negative 16, so I'll have a negative 16x, and 2 times negative 20 is a negative 40. And that's exactly what I started with, so I factored it correctly. I sometimes like to just put a little check mark to say, yay, I did it right. But one thing I really want to stress here is you can always check your factoring by distribution. I always recommend that until you're really comfortable with your factoring abilities. So let's look at another example here. Again, the first thing we would always want to do is just check for a greatest common factor. And if you look at all 3 of these terms, they have nothing in common, so they don't have a greatest common factor. I'm just going to start off by then putting my parentheses, my 2 sets of parentheses, and I'll say, okay, well, if I'm looking at n squared here, that's going to be n times n. And then I want to look at this positive 56 at the end here. There's a lot of combinations for positive 56, and I can just start listing them. So maybe I'll just kind of write those off to the side. I'll do 56, and I'll say, okay, well, what times what is 56? Maybe we could do like 56, or sorry, 2 times 28 is 56. We could think of some others. One of the ones that comes to mind is 7 times 8. I don't know. We can just kind of play with them. If you look at this negative 15 here, and we could make more in this list, but 7 plus 8 is 15. Another way I could write it is negative 7 times negative 8. And a negative times a negative would give us the positive that we need there. And then also the negative 7 plus the negative 8 will give me the negative 15 that I need. So my factor, I'll have a negative 7 there and a negative 8 there. And that would be my final answer. I would circle that, but I could definitely go through and check just to make sure that I factored it correctly. And I would just put, well, n minus 7 times an n minus 8, and I would just kind of distribute n times n times negative 8, negative 7 times n, and negative 7 times 8. Or sorry, negative 7 times negative 8. And if I did that correctly, I would have n squared minus 8n minus 7n, and then a plus 56. And then Those two middle terms, the -8 and the -7, give me a -15. And since I ended with what I started with, I know I factored it correctly. And then that would mean that n minus 7 times n minus 8 would be my correct factor. As we're going in factoring, one thing I just always want to stress is we're always looking for a greatest common factor. So if we look at these three terms here, if you notice they all have a 3. 5 times 3 is 15, and 6 times 3 is 18, and then they all have an x squared as a term in there. So when we factor this, we want to make sure we pull out that greatest common factor. We'll have a 3x squared out here, and we'll be left with x squared plus 5x, and then plus 6. And then once we get to that point, we'll have the 3x squared out front. We'll have the two sets of the parentheses. And we'll just go ahead and factor out this piece, kind of like we've done in the previous problems. We've got x squared, so I'll have an x and an x right there. And then we'll also look at the 6. Now we could think of a couple of combinations for 6. We could think of 6 times 1, but 6 plus 1 doesn't equal 5, so that won't work. We could also think of 3 times 2, which equals 6, and 3 plus 2 does equal 5. So I'll end up writing a plus 2 and a plus 3. And we could then go ahead and multiply it out, but hopefully you're starting to see now that if we're careful enough, we have the correct factor and we can just circle our answer. But again, if you're not 100% sure, go ahead and pause the video and multiply this out, and you'll see that we end up with the same thing that we started with. So again, get in the habit of looking for a greatest common factor. So in example 4 here, we have a 6x to the 5th plus 24x cubed plus 3x. And we're just going to see what they have in common and factor those out. If you notice that there is a 3 in common, 3 times 2 is the 6, and 8 times 3 is 24, and then 3 times 1 is 3. Then if you notice, each of these have at least an x in there. So we'll pull out a 3x as our greatest common factor. And then we'll be left with a 2x to the 4th plus a 8x squared, and then plus a 1. I think the 1, a lot of times I see students leave that off, but it has to be there. It kind of acts as a placeholder because 3x times 1 gives me 3x squared. And another thing that we'll then try to do is just factor this part. But if you notice, this is an x to the 4th, and we're really focusing on factoring quadratics in this unit. In secondary 3, we'll talk about factoring things that have higher powers like x to the 4th or x cubed. But for now, in secondary 2, we're just going to stop there. We're going to circle our answer, and we're not going to continue. Don't worry necessarily if that happens. Some problems aren't factorable, such as this one with that x to the 4th. So in example 5, we're looking at an 7x squared plus 2x minus 9. If you notice, there's nothing in common between the 7, the 2, and the -9. There's no greatest common factor that we can factor out. And so this problem presents a little bit of a unique problem for us that we have to kind of change our strategy just a tiny bit for. But we're still going to do the same basic idea. I'm going to have two sets of parentheses, and then I'm going to think, well, what times what is 7x squared for that piece and that piece? Well, 7, the only combination to break that up is 7 times 1, so I'll have a 7 and then a 1 in the next place, but I won't write it because it's more of a placeholder, and then I'll also have an x and an x because of the x squared. Now, I also have to think about, well, what times what is -9? There's a 3 times 3, and there's 9 times 1. That's really the only options where one of those has to be negative. And let's look at the 3 times 3 first. We'll put a 3 there and a 3 there, and let's just kind of see what happens. If you then go ahead and try to multiply it out, and we'll make one of these positive and one of these negative, just because it needs to add up to a -9 or multiply to a -9. I'll do 7x times x and 7x times negative 3 and 3 times x and 3 times negative 3. Again, we always want to check just to see if this works. And so 7x times negative 3 is going to give, 7x times x gives me 7x squared. And then 7x times negative 3 is a negative 21x. 3 times x is a positive 3x. And then 3 times negative 3 is negative 9. If you multiply that out and you look at kind of these middle terms here, there is no way that is going to add up to our 2x that we want it to. So that combination clearly didn't work. And it wouldn't have mattered if I would have made the other one positive or the other one negative. That just doesn't work. And so we're going to have to try something else. So I'm just going to erase this and let's try to figure it out using kind of another way. So we'll erase that 3 and erase all of this. And so one of the other things I could have done was a 9 and a 1. So I'm going to write the 9 here and then the 1 there. And let's just see how that works. So I'm going to do now, and let's make the 9 positive and the 1 negative. So we'll do, and just check that out, we'll do 7x times x and 7x times negative 1, and then 9 times x and 9 times negative 1. And that gives me 7x squared minus 7x plus 9, and then minus 9. Sorry, plus 9x. And then if you look at these middle terms, they do actually add up to a 2x. So I would have 7x squared plus 2x and then minus 9. And that's what I started with. So in the end, this 7x plus 9 times x minus 1 is the correct answer. It's harder to figure that out when you have a leading coefficient that's not 1. In our case, we had a 7. But because what happens is this 7, when it multiplies to, say, the negative 1, now affects this term and this term right there, how they add up. So you just have to be a little careful with that. It just takes a little bit more thought. Let's look at one more problem similar to example 5. So the first thing we'll do again is always look for that greatest common factor. If you notice, I have a 4, a negative 10, and a negative 25. And so a negative 24. So they all have a 2 in common. So I'll factor out that greatest common factor of a 2, and I'll be left with 2x squared minus 5x minus 12. And now I'll just go ahead and factor this kind of like I factored example 5. So we'll have equals, and we'll keep that 2 that we factored out. That hasn't gone anywhere. And for these first 2 points right there and there, I'm going to think of, well, what times what is 2x squared? And that's just going to be 2x times x. Now I've got to think about, well, what times what is negative 12? And I've got to make sure I incorporate this 2 as I do it when I try to add up to this negative 5. So for negative 12, I could think of 2 times 6. I could think of 12 times 1. I could think of 4 times 3. And so let's just play with it. My personal strategy of choice is to try the lowest 2. So if I just write those out, 12, and then I'm thinking, well, 3 times 4, maybe 6 times 2, and then 12 times 1. I'm always going to look at the combination that has the lowest 2 numbers. So if you look at 3 times 4, 3 and 4 are both smaller than 6 and 12. So I'm just going to try that one first and see if it works. If it doesn't work, I'll go on to the next ones. That's just a strategy that I found that works pretty well. So let's try that. I'm going to put the 3 here and the 4 here and just kind of see what happens. We're going to do 2x times 4, and that gives me 8x. And then 3 times x gives me 3x. And I really only need to check those 2 because those 2 will end up adding up to my negative 5x. And if you notice, 8 and the 3, that will add up to 5. If maybe the 8 were negative and the 3 were positive, that would add up to a negative 5x. So I'm going to make this 4 negative, and then I'm going to make the 3 positive. And again, if you kind of notice, so this 2x times negative 4, that gives us our negative 8x, and this 3 times x gives us our positive 3x. And so this expression right here would be our answer. That's what I would circle. And you could go ahead and multiply that whole thing out if you'd like, or kind of a quicker way to check is we're really just needing to check these two to see if they add up to our middle term. That's usually where most people get stuck. All right, one last type of problem I want to look at. This is a special case where you don't necessarily have a middle term. We call this a difference of squares. The word difference comes from the subtraction sign, and the squares comes from the fact that we have an x squared there, and 9 can be written as 3 squared. So we're taking two squared numbers and we're subtracting them. Thus the phrase difference of squares. There's a couple of ways you could look at it. One of the ways that I know of, is to think of this as x squared plus 0x minus 9. And this 0x, 0 times x is just 0, and that's kind of what's happening there. So then we could go ahead and factor this just like we factored some of our other problems. There's no greatest common factor, so you don't have to worry about that. And I'll put my two sets of parentheses. And x times x gives me x squared. And then we've got to think of two things that multiply to negative 9, and that would be a positive 3 and a negative 3. And if you go ahead and check this, and we do like x times x, that's x squared, x times negative 3, and then 3 times x, well, those will add up to 0x, and that's kind of why there's no middle term there. And then 3 times negative 3 is negative 9. So that would be our correct answer. One of the other ways to maybe think about this problem is really just to memorize it. This setup comes up so frequently, a difference of squares, that I really want you to kind of just have this memorized. Another really quick problem we could look at that's just very similar is maybe something like x squared minus, let me get my eraser out, minus 25. And that would just simply factor to x plus 5 times x minus 5. And again, difference of squares come up so frequently, just make sure you kind of have those memorized. Okay, let's just briefly look at 3 more examples to kind of just wrap up this factoring stuff. And so let's look at the first one. It's kind of one of those easier cases, so I'm just going to put my two sets of parentheses, and I'm going to have an x and an x from my x squared, and then I'm going to look at that negative 13. Negative 13 is kind of nice because it's a prime number, so the only possible case is 13 times 1, but I need to decide which piece is negative and which piece is positive, and since I need it to add up to a positive 12x, and I need the 13 to be positive and the 1 to be negative. All right, and then I could definitely go through and multiply that out to check, but it definitely will work. Let's look at this second one here. This one is, again, one of those harder cases where we have a number right there that's other than 1. The big difference here is that is just a 1 and this is a 5, so this changes the problem quite a bit. So what I do know, though, is I do know that I'll have two sets of parentheses, and whatever goes here and here needs to multiply to a 5x squared. And so 5 times 1 is 5, and then x times x. So I'll have a 5x and an x. And then as I look at this 3, that's kind of nice to deal with because 3, the only way to break that up is 3 times 1. So it's really just a matter of deciding where to put the 3. Should I put the 3 there or should I put the 3 there? Let's look at both cases and kind of see what happens. So I'm going to first put the 1 there and the 3 there, because remember 1 times 3 is 3. But when I look at that and I multiply out, I'll do 5 times 3, which is 15, so I'll have a 15x, and then a 1 times x, which is a 1x. There's no way that's going to add up to 8. So let's erase that and see what else we might be able to do. Okay, so one of the other option we have is we can put the 3 here and the 1 there. And then we can multiply that out and check. We can do 5 times 1 and then 3 times the x, or so I should have said 5x times 1, which is 5x, and then 3 times x, which is 3x. If I do add those up together, they do equal 8x. And I don't need to worry about a positive sign or a negative sign, and so I can have a positive there and a positive there, and that would end up working out. And I could multiply the whole thing out and check, but just from experience, I know that that will work out for sure. So let's erase all these pieces and clean that up a little bit, and I should be good to go. So let's look at this very last problem for this section. It's also a difference of squares, similar to the previous example we looked at on the last slide. One way to think about this is 3x squared, because 3 squared is 9, and then x times x, or x squared is x squared. And then minus, we could think of this as 4 squared, because 4 times 4 is 16. So that is a difference of squares. I kind of want you to get in the habit of just memorizing how that's going to work. So I would have 2 sets of parentheses, and I would have a 3x plus 4 and a 3x minus 4. One of the other ways you could look at it is you could look at this as 9x squared plus 0x minus 16, and then kind of go through and factor that, similar to how we did number 2 right here. But I do want you to get in the habit of just memorizing that when you see something like this, you say, oh, that's a difference of squares, and you can immediately factor that. So that's about it for the factoring. I think that the hardest parts are ones like number 2 here. Go back through and watch those examples again if you need to, and then like I said, we'll definitely spend more time on those in class over the next couple of units. Right now I just want you to get exposed to them, and then definitely try your best to factor those.